humans think about living in space, you often jump to the idea of traveling to other worlds and colonizing their surfaces. Even planets with deadly environments could be tamed with enclosed habitats and terraformation. But is this the most efficient way to live in space?
Based on that question, I can tell that it isn't.
Quiet you. Your idea of space is often defined by the planets in the solar system: small rocky Mercury, hot hellish Venus, frozen barren Mars, and so on. But what is often ignored is the wide expanse in between. Looking at scale models of the solar system reveal that there is a lot of space in between the planets that you focus on. So why not use it?
Because it's empty. It's such a trek to get in between any two planets.
You know very well that we can travel at light speed. Now, come on.
Fine.
Part 1. The Basics of Space Stations. A space station can be a pretty simple contraption if you want it to be. Bigelow Aerospace's B-330 is pretty much just a giant balloon with solar panels attached to it. Now, while it isn't as simple as that, and requires some impressive engineering,
Impressive for human standards.
my point is that it isn't that hard to build a habitat in space. All you need is a system to recycle air and water, a system to grow food,
We don't eat food.
climate controls, and radiation shielding. And you have a self-sustaining space station that you could live on indefinitely.
That radiation shielding kicked me out of the space station.
Sorry. There is one glaring problem with this space station: gravity.
Hey,
Not you. I'm talking about the lack of gravity in space. The defining feature of life on a space station seems to be a lack of gravity,
I still can't get in there.
and this lack of gravity results in medical problems. The weakening of muscles and bones, as well as eye problems from fluid rushing to the head, are such that you don't want to leave any astronaut in space for very long. The longest continuous stay in space was 438 days long, a few months longer than a year. Not what you would consider permanently living in space. So, do you have to give up on living in space? Should you just resign yourself to the surface of planets? Not necessarily.
Here we go again.
Part 2. A Substitute for Gravity.
Hey, I'm irreplaceable.
If you have seen any sci-fi movies or TV shows that take place in space, you might be wondering why everyone isn't just floating around. For some reason, explained as artificial gravity, the people and objects in space manage to stay on the ground. While the older films explain it with gravitons or other forces outside of known physics, more modern tales in space take advantage of a simple concept that you can experience the next time you are driving. If you have ever driven down a windy road, then you know the nuisance of this force in action. As your car turns right, your body lurches to the left, and when your car turns left, you find yourself leaning to the right. This is because of Newton's first law of motion. An object in motion will tend to stay in motion. As you and the car move in a straight line down the road, everything is fine. But when the car turns, your body continues in the same direction it was going before, which makes you lean one way or another. This feeling of being pushed in either direction is known as centrifugal force.
Hello.
But it isn't an actual force. It is just that your surroundings are changing directions without you. Despite not being an actual force, its effects can be felt, and it can be applied to space.
Seriously?
A space station constructed in the shape of a ring or a cylinder that spins at an appropriate speed would allow its residents to stand up on its circular walls and walk around over what they would perceive as level ground.
Wait, holograms don't need to worry about gravity.
With this method, space habitats could be built for permanent habitation as the people in it wouldn't be plagued with a lack of gravity.
Wow, I guess I can be replaced.
Part 3. Problems with centrifugal force.
Haha, there is hope for me yet.
As with anything, centrifugal force isn't perfect. The main problem is how it restricts the size of a space station that wants to use it for artificial gravity. On the small end, centrifugal force requires a space station to be over about 200 meters in radius to be comfortable for people to live in permanently. In order to achieve Earth-like gravity at this radius requires the space station to rotate twice every minute, Any smaller than this, and more than 2 RPM would be required to maintain that much gravity. This may be fine for trained crew for short periods of time, but not for long-term civilian habitation, which is what you're looking for. On the upper end, however, is the structural integrity of a ship. Since centrifugal force acts just like gravity, any space station using it would have a tendency to fall apart.
Stop copying me.
Just like how you can't build huge bridges or skyscrapers without advanced techniques and strong materials, the upper limit on a space station's size would be based on the strength of the materials it is made out of. Considering the fact that the ISS, your biggest current space station, has a diameter of 100 meters, you have a quadrupling of size to accomplish before you could employ this method of artificial gravity on a space station. But once you do accomplish this, would all you humans really want to live in an enclosed habitat?
Humans are so picky.
Part 4. The beauty of a large space station. Say you had a space station with a radius of 5 kilometers and a length of 30 kilometers. When unwrapped, a map of its interior would give you a 30 kilometer by 30 kilometer square. That is well over the area of New York City, meaning that you could sustain a population of 10 million with similar population densities. What would life be like in a space station like this? The immensity of the structure allows for houses and even skyscrapers to be built within what would be an open-air structure. My point here is that you could have kilometers of plains or forests without a building in sight in one of these space stations.
Hello?
So, they shouldn't be thought of as enclosed artificial habitats. If you were to look upwards in one of these space stations, what you would see would be the ground on the opposite side of the station. Since you would live on the inside of a circle, there would be no sky, just the ground opposite you. Thankfully, though, the larger the space station, the hazier and bluer the other side will look to you. Just like how distant mountains and skyscrapers look blue, sufficiently large space stations could give you a blue sky like normal. How about a sun? How would you get light into one of these space stations when they are enclosed and dark on the inside? The answer is an array of reflective mirrors to channel sunlight, or a solar-powered light bulb powerful enough to shine light through the whole habitat. Either way, a realistic-looking sun can be achieved. With a realistic sun and a possibly realistic sky, these places seem like they could simulate Earth pretty well. With a good designer, these space stations would be incredibly happy rather than dreary.
I'm starting to be sold on them myself.
Part 5. Why not planets and space stations?
Yeah, why not both?
These space stations seem great and all, but why not live on the surfaces of planets too? The answer is that compared to space stations, living on the surface of a planet is incredibly inefficient. When living on a planet, you have thousands of kilometers of rock beneath you to support the surface you live on. On a space station similar to the ones we discussed before, any more than a few hundred meters of casing would be excessive. Clearly, there is a discrepancy here, and when it comes to mass versus living area, space stations beat planets by many orders of magnitude.
Wow.
As a result, it makes much more sense to completely mine out a planet, harvest all of its resources, and turn them into a fleet of space stations than to live on its surface. With the usable mass in the solar system, humanity could create enough space stations to support quintillions or sextillions of people.
That exceeds my processing power.
There is another limiting factor to the possible number of humans you could support: the energy it takes to keep them alive. Next episode of mine, we will discuss the primary method of obtaining said energy, a Dyson sphere. In the future, we may also look at a way that we could hold on to our planets and get the materials inside of them, creating structures called shell worlds.
I hope you enjoyed this video. For more content on science, make sure to like and subscribe.
Thank you.
And goodbye.